So these first two questions are kind of similar to the baseball question, but this yard darts one is a little bit different. So that's what I want to take a second to talk about. So Tony and Sue, they're having a great time, and they are launching some yard darts. The yard darts start 20 feet from the front edge of a circuit. Now, right now that doesn't do much for me, but I will say that's going to end up acting as an important horizontal distance later. The radius of 18 inches, which would mean a diameter of 3 feet, and that might be helpful for our horizontal distance later. So far, though, that hasn't told me much in terms of all these formulas we have. If Tony throws the dart directly at the target and releases it 3 feet above the ground, that's our initial height. That's when it leaves his hand and it's now a projectile and not just a thing in his hand. With an initial velocity, we know that that's going to be helpful. At a 70-degree angle, kind of a steep angle, will the dart hit the target? Now, some information here. We have talked about the y distance of being 20 feet. The hitting of the target, that's going to happen when it hits the target's on the ground. That's probably an important clarifying piece of a yard dart, is that the target is on the ground. So we want to know, when we get to the ground, did we hit a target that's 20 feet away? Okay, so let's kind of set it up the same thing, but I'm going to do y first. Let me back that up. I'm still going to do the vector first, but then I'm going to use the y equation. So let's do our vector. So we've got v naught cosine theta, v naught sine theta, and our initial velocity is 30 feet per second, cosine of 70, kind of insane, 30 feet sine of 70. And so our initial vector looks like this. So 30 cosine 70, 30 sine 70, and we've got 10.26 for the x velocity and 28.19 for the y velocity. So it's definitely going up a significant amount, which makes sense because 70 is a pretty big angle. Not all the way to 90, which would be straight up, but it's pretty big. Now, it's flying through the air, and we want to know, when it hits the ground, does it hit the target? That's our question. So we got to find out when it hits the ground and then figure out how far did it go. So here we go. The second piece I'm going to look at that y equation. So negative 16 t squared plus v naught sine theta t plus y naught. So negative 16 t squared. Okay, so I don't know what t is. So we're going to solve for it. But I do know that my goal is to land on the ground. Plus 28.19 t plus an initial height of 3, because that's where he released it. Now I want to solve this. I've got a couple ways. I can use the quadratic formula, which is a great tool, and it's something we definitely want to have in our back pocket. Or I can do this. I can do it in Desmos, because graphing an equation is always an option. So Desmos, and I'm going to graph that equation. So I've got negative 16. Desmos doesn't like the letter t because it's likes to work with x's and y's, which is fine. We can adapt and adjust. We're just fine. And plus initial height of 3. So here's kind of the path here a little bit. There's our graph of what's happening in terms of y. And so now my time is 1.86. In other words, to go up and back down, it takes 1.86 seconds. Okay. If you want to see that, whoops, I don't want 0 there. If you want to see that in terms of the quadratic formula, it would look something like this. T equals negative 228.19 plus or minus the square root of b squared minus 4ac all over 2a, right? Crazy heavy math, crazy plugging stuff in, all good, very fun, very much, I don't know, kind of my jam. Hopefully it's a little bit your jam too. So we would punch all that into a calculator. And we get the same thing, right? It tells us the same information. It actually is going to give us both answers because of the plus or minus. But the moral of the story is, in order to get back to the ground, it takes us 1.86 seconds. Now, in order to get back to the ground, it also has traveled horizontally. So let's now dive into that. So we've got our cosine theta times our t. I don't know how far it is. I'm hoping I hit the target of 20 feet away. My velocity is 10.26. My time is 1.86. And my distance is not looking so hot. I'm at 19.10 feet. So the front edge is 20 feet away. So we are close, but not on the target. It's a terrible looking target. Let's just refix that because no one needs to see that. So that's what's different with this question compared to the, sad my star didn't come with. Compared to the other one we did at the start, was here we knew we were getting back to the ground and it was the X distance that we were not so sure about. And the other one, we knew we were going 400 feet and it was the Y distance. So start with what you know and then use that equation, whether it's X or Y, and then go from there. So you got this. Let me know. Keep me posted if there's more we're not sure.